Good. Now, circular motion. When and why something moves in a circular path? Let's discuss. For example, if there's an object which has been engaged by a force, this is the direction of velocity of the object, and it is engaged by a force which is in the direction of the velocity. There is another object. This is the direction of velocity of the object, and it is engaged by a force opposite to the direction of velocity. And there is the third case. This is the object. This is the direction of velocity, and instead it is engaged by a force perpendicular to the direction of velocity. So what will happen in case 1, what will happen in case 2, and what will happen in case 3? This is a mass m, which is with the velocity v, and it is exerted by a force in the direction of velocity. So if the net force is acting along the direction of velocity, acceleration produced in the direction of velocity, that will increase the speed of the object. A positive acceleration is produced velocity increases. Object accelerates, the velocity of the object increases, the speed of the object increases in the same direction as it was going. Now, if object is moving in the forward direction, towards right, for example, over here, and the force that we engage it with is acting opposite to the direction of the velocity. This is what we do when we apply brakes on a car. The net force is acting opposite to the direction of velocity. What happens? A negative acceleration. And I'm using this positive and negative in terms of velocity. Okay. Negative acceleration, which is also known as deceleration, is produced. Velocity decreases. But these two cases are what we are discussing today. We are here for the third case. A mass m, which is moving towards right like this, and it is engaged by a force which is simultaneously perpendicular to the direction of velocity. So what will happen? The object will not speed up. Neither it will slow down. Then what will happen? The direction of motion of object will change. So instead of going where it was going earlier, the object might start to go there. Sorry. Might go there with velocity going this way. Velocity is still this way. And now force is acting like this. Still, force is perpendicular. Force is still perpendicular. to the velocity. So what will happen is, this is force, this is velocity. The object will change its velocity again. So if this keeps happening every time, then we are supposed to observe something like this. Just 1 second. So we can observe something like this. The velocity is now this way, and object is moving in a circular path. So after some time, object might get here, force will be acting this way, and velocity will be this way. There will be a time, object will get here, velocity will be this way, and force will be this way. Object will get here, velocity will be this way, and force will be this way. So force is always going to be perpendicular, because force is not accelerating the object along the direction of velocity, neither it is decelerating the object opposite to the direction of velocity. This force is only changing the direction of motion of the object. Okay, what are the important things about this force? Is this force producing any change in speed? Answer is no. But is this force changing velocity? Answer is yes, because it is continuously changing the direction of the force, the direction of the motion. So, and then one more thing, although it is a consequence, because this force is always perpendicular to the tangential velocity, it always acts towards the center of the circular path, so we call it centripetal force. The force that compels an object to move in a circular path is called centripetal force, and it always acts towards the center of the circular path. Now, some of the students get confused over here, and they think that the direction of force is fixed. Remember, if something is pointing towards the same point from different positions, it is not in the same direction. Although the force is pointing towards the center of the circular path, but it is not in the same direction. The direction of force and direction of velocity is continuously changing. Now, centripetal force, F. Now, is it easy to make a heavy object turn? or is it easy to make a light object turn? What do you think is the centripetal force, the relation of centripetal forces with the mass of the object?
It's easier to move a light object.
So that means centripetal force is directly proportional to mass. More mass will require more force, less mass will require less force. Now, is it easy to change the direction of a fast object, or is it easy to change the direction of slow object?
Slow.
Centripetal force is directly proportional to speed square. Now, centripetal force, and is it easy to make something move in a bigger circle, or is it easy to make something move in a smaller circle? Before you answer the question, let's think. If you are making a car move at say 100 km per hour, at 100 km per hour, is it easy to turn the car in a smaller curve, or is it easy to move the car in a bigger circle, bigger curve?
Bigger.
So it means that for a bigger circle, you require less force. That means centripetal force is inversely proportional to radius of circular path. So if we merge these three things, we will end up with the formula for centripetal force, which is centripetal force equals to mass speed square divided by radius of the circular path. Now, this is a very important formula. Units, remember in these formulas, units are very important. You cannot use any unit you want to. If mass is in kgs and speed is in meter per second, radius is in meters, then centripetal force will be in newtons. Okay, in different cases, different things provide this centripetal force. Okay, this is just a name given to a force that is making an object move in a circular path, but it is not a source of force. It has to come from any source. For example, sometimes friction is providing this centripetal force, sometimes tension is providing centripetal force, sometimes electric force is providing centripetal force, sometimes gravitational force provides centripetal force. Let's see some examples where these forces are making making an object to move in a circular path. For example, let's make a list. Example: source of centripetal force. Example number 1: a car moving on a circular track. What provides centripetal force? Answer is component of friction acting perpendicular to velocity. Let me explain this to you. Let's say this is a car. This is car as seen from the top. Okay, we are looking at a car from a helicopter. So we are looking at the car's top. Okay, and this is the car when it is moving on a straight path. These black lines are showing the tires. Or this is when the car is moving on a straight path like this. What if we turn the wheel? What happens? In this case, in the first case, this is direction of friction between road and tires, and this is direction of motion. But here, what we do is we turn the tires a little bit like this and this. What happens now?
Sir,
Yes,
wouldn't friction be in the opposite direction of motion?
no, in this case, because the tires, the friction between the road and the tire is actually the force that drives the car.
Oh yeah, okay, makes sense.
Look, the tire is trying to go backward on the road. Look, or try to focus on the tire of a moving car, and you have to focus on the lower end of the tire, which is trying to go in the backward direction with respect to the point on the floor. But it cannot go backward because of the friction. So friction pushes the car in the forward direction. So
Okay.
this is direction of motion of car. But now the direction of force is this way. Friction between road and tire. So what happens is there will be two components. One component of force is like this, and one component of force is like this. Now, this is component of friction along motion, and this is component of friction perpendicular to velocity. Can you tell me which one will be responsible for the turning of the car?
The perpendicular one.
Yes. So this is why the car moves in a curve path when we turn the wheels like that. Now, example, source of centripetal force. Example is a planet orbiting a star in this case, or there can be many other satellite orbiting a planet What will be the source of centripetal force in these cases? The gravitational force provides the required centripetal force. Okay. Now, an electron is orbiting a nucleus. What do you think? What will provide this required centripetal force in this case? The nucleus is positive. The electron is negative. They attract. So, electrostatic attraction will provide the required centripetal force. Now, an object is tied with a string and moved in a circular path. Let's, for easement, consider it as a horizontal circular path. What provides a centripetal force?
The tension on the string.
If a mass is attached, yes, if a mass is attached to a string, then to move it in a circular path, that string has to be taut. String has to be under tension. Otherwise, the object cannot move in a circular path. So the tension in the string or component of tension in the string provides the required centripetal force. If you're a cyclist and you drive or ride a cycle or motorbike, you might know that a motorbike is not controlled with the steering. For example, if there's a car in front of you and you're on a motorbike, you won't steer the bike left and right and change the lane. What a biker does is biker just change the direction of weight. So what you do is you just put weight on one side of the bike and the bike starts moving towards right and towards left. Okay, so that is also an example of making using a component of weight to change the direction of motion. You might have seen a motorbike race there when to get that required component of weight, which is very high to move the bike in a very short and very at very high speeds, to make a bike move at a very um, uh, sharp turn. The bikers, they move, or they lean to one side so that their knees are hitting the ground. Why do they do that? Actually, they need a very large component of their weight to make the bike move in a circular path over there. Okay. Again, they are using their component of weight to do that. Now, let's discuss the formula of the centripetal force. Yeah. Centripetal force is mv square over r. Centripetal acceleration is what? Answer is centripetal force is m times centripetal acceleration. We can compare that to find what should be the centripetal acceleration. Fc equals to m ac. Compare. What will be centripetal acceleration equals to? It should be equal to v square over r. So this is a formula for centripetal acceleration. Now, what else can we do today? One more thing. I do not want to go into uniform circular motion today. That has to be done tomorrow. Okay, let's end today's lesson over here. We will resume from the same point tomorrow.